You know that invisible force that keeps your feet planted firmly on the ground? The one that holds the moon in the sky and basically runs the entire cosmic dance of the planets? Well, today we're diving deep into that amazing, mysterious force we call gravity. But to really, truly understand just how powerful it is, let's start with a crazy idea. What if, in the next second, gravity just switched off? Poof, gone.
Okay, picture this. You're not waking up to your alarm clock. You're waking up because you're floating off your bed. Your phone, your lamp, everything in your room, your whole city just starts drifting away, untethered, into the sky. It would be absolute chaos. That nightmare scenario is exactly what gravity prevents, every single second of every single day. It's kind of the silent hero of our universe. So what is this fundamental force really?
You know, at its heart, gravity is beautifully simple. It's a force of attraction. That's it. Any two things that have mass, anything made of stuff, are going to pull on each other. It's never a push, it's always a pull. And this right here perfectly illustrates the golden rule of gravity. Mass is king. The more massive something is, the more powerful its gravitational pull. Tiny little objects pull just a tiny little bit, but huge, massive objects, well, they pull a whole lot more. And get this, that's right, you have your own gravitational field. But you know, it's incredibly weak. You're not going to pull your coffee mug across the table with your mind because your mass is just minuscule compared to the Earth. It's the planet's colossal, enormous mass that creates that powerful force you feel all the time. Now, this brings us to a really, really important point, something people get mixed up all the time, the difference between mass and weight. Your mass is just the amount of stuff you're made of. It never changes whether you're here on Earth or all the way on Jupiter. Your weight, though, oh, that's a different story. That's just the measure of gravity's pull on your mass. So, the next time you step on a bathroom scale, remember this. It's not actually measuring your mass. Nope, it's measuring the force with which the Earth is pulling you down. That number you see, that's your weight. It's basically a force meter. And this is where it gets really fun, seeing how much that pull can change depending on where you are. Take a look at this. A 3-kilogram book right here on Earth weighs about 30 newtons. Okay, fine. But take it to Mars, and suddenly it only weighs about 11 newtons. But on the gas giant Jupiter, whoa, its immense gravity makes that very same book weigh almost 78 newtons. It's the same book, same mass, but a wildly different weight. Okay, so gravity keeps us on the ground. Got it. But how does that scale up to keeping our entire solar system in order? Well, it's a truly cosmic balancing act. I want you to try and wrap your head around this number. Right now, this very second, you are hurtling through space. The Earth is moving around the sun at about 100,000 kilometers an hour. Just incredible. Think about that for a second. If you were on a merry-go-round spinning that fast and you let go, you'd be flung off in a straight line, right? Well, the exact same thing applies to our planet. Without some kind of anchor, some kind of tether, it would just shoot off into the cold, dark void of space. So, what is that cosmic tether? What is the anchor that keeps us from being lost in space forever? Yep, you guessed it. It's gravity. The sun is just so massive that its gravitational pull acts like this constant, invisible rope, always tugging on the Earth. Our planet wants to fly straight, but the sun's gravity keeps bending its path. And this perfect balance, this beautiful dance between moving forward and being pulled inward, that's what we call an orbit. So speaking of orbit, that brings us to one of the biggest misconceptions about space. You know, we see astronauts floating around and we immediately think, aha, zero gravity. But is that what's really going on? Let's just ask it straight up. When an astronaut is orbiting the Earth, have they completely escaped gravity's pull? The answer is a big, fat nope. Not at all. Actually, the force of gravity where the International Space Station orbits is still about 90% as strong as it is right here on the surface. So if gravity is still pulling on them, why in the world do they float? Well, the answer is one of the coolest ideas in all of physics. They aren't floating. They are falling. Constantly. It's a mind-bending concept called free fall. Think about being on a swing at the playground. When you jump off at the highest point, for that brief moment before you start to plummet, you feel weightless. That's what's happening in orbit, but it never stops. The space station, the astronauts, and everything inside it are all constantly falling around the Earth together. And since everything is falling at the exact same speed, it creates that incredible sensation of floating. So, gravity isn't just about planets and astronauts. It has these really subtle and sometimes powerful effects right here in our everyday lives. For example, take the world's tallest building, the Burj Khalifa. The very tip of its spire is quite a bit farther away from the center of the Earth than someone standing down on a sidewalk. And because gravity gets weaker with distance, even by a little bit, it means you literally weigh less at the top of a skyscraper than you do at the bottom. The difference is minuscule, of course, but it's real. It's a measurable fact. And its influence is just everywhere. It's the moon's gravity pulling on our oceans, creating the daily rhythm of the tides. It's the reason our planet is a sphere and not some giant lumpy potato floating in space. It's what athletes have to master to maintain their balance. And of course, it's the #1 challenge engineers have to beat when they're designing rockets to send into space. You know, when you zoom all the way out, from the smallest atom to the biggest galaxy cluster, gravity is the universal glue. It holds our world together, our solar system, our entire galaxy. So, the next time you feel that familiar, constant pull, just take a moment to think about it. And maybe ask yourself, what is gravity holding together in your world?